What to know about X-linked inheritance and muscular dystrophy. Have you ever wondered how certain genetic conditions are passed down through families? One fascinating aspect of genetics is X-linked inheritance, which plays a significant role in muscular dystrophy. X-linked inheritance occurs when a gene responsible for a condition is located on the X chromosome. In humans, females have two X chromosomes, while males have one X and one Y chromosome. This difference is key to understanding why muscular dystrophies primarily affect males. Muscular dystrophies, particularly Duchenne muscular dystrophy and Becker muscular dystrophy, are caused by mutations in the dystrophin gene found on the X chromosome. These conditions follow an X-linked recessive inheritance pattern. For males, having only one X chromosome means that if their X chromosome carries the mutation, they will develop the disease. They do not have a second X chromosome that could potentially carry a normal version of the gene. In contrast, females have two X chromosomes. This means they would need mutations in both copies of the dystrophin gene to show symptoms of the disease, which is quite rare. Typically, females with one mutated copy are considered carriers. They usually do not show symptoms or may have milder symptoms. However, in some cases, female carriers can exhibit symptoms due to a phenomenon called skewed X inactivation. This occurs when the X chromosome with the normal gene is inactivated more frequently than the one with the mutation. When it comes to inheritance risks, a female carrier has a 50% chance of passing the mutated gene to her sons, who would then be affected. She also has a 50% chance of passing the mutated gene to her daughters, who would become carriers. On the other hand, fathers with the mutation cannot pass it to their sons since they pass the Y chromosome to their sons, not the X chromosome. It is also important to note that new mutations can occur spontaneously in the dystrophin gene. This means that some cases of muscular dystrophy can arise without any family history of the condition. Clinically, males with Duchenne muscular dystrophy or Becker muscular dystrophy typically show symptoms like muscle weakness starting in early childhood, with Duchenne being the more severe form. Female carriers may experience mild muscle weakness or heart-related symptoms, such as cardiomyopathy. In summary, understanding X-linked inheritance is crucial in explaining why muscular dystrophies linked to the dystrophin gene predominantly affect males. Females usually serve as carriers with little to no symptoms. This knowledge is essential for genetic counseling, diagnosis, and family planning in the context of muscular dystrophy. It also emphasizes the importance of personalized medical advice and monitoring, especially for female carriers who may have subtle symptoms or cardiac risks.